in any case, we were talking about performance monitoring and optimization of pollution control equipment. With the real-time SEMS and electronic SEMS, you can see what's going on. You can look at the influence of changes of rates of activated carbon injection, for instance, on the reduction of mercury, and you can see whether you're meeting your objectives. And finally, you have an electronic record that if you have to report to the state or to the federal government, which you will have to, then you can facilitate that by having electronic SEMS and electronic output. Next slide. The frequently asked question 6 I put up, can you have multiple SEMS parameters on the same umbilical? There's really a two-part answer here. We can't, with mercury, for instance, use the line that is typically used for SOx and NOx for mercury. There's some additional transport and calibration work that we do on a system-wide basis, but we also maintain, and intentionally so, a heated umbilical and on the order of 180 C, 350 plus F, to minimize the loss of ionic mercury, which is kind of a sticky, tacky substance that'll get lost along its way unless it's heated. We have successfully teed in total hydrocarbons into our system and are offering that. We have a number of months, if not maybe up to a year experience with that. And so we're continuing to look at how might you save some money and do combined transport, if you will, of multiple pollutants that are added to our mix here. Next slide. I've talked about PMEMS here in this slide. There's a number of different technologies. There's also an Olympics underway at the DTE Monroe plant that the Electric Power Research Institute is sponsoring. They're looking at a number of different technologies, many of which are in their upper check marks. And if you look at the last couple check marks there, those projects are underway, and it's perhaps the case, Bob, that the coal-fired power plant industry and the work that's being done there can benefit the cement industry and vice versa in the area of PMEMS. Next slide. Total hydrocarbons, another new pollutant we happen to be using in our system, and it's not an advertisement for that or us, but we're successfully using the California Analytical THC monitor along with our 3300 mercury SEMS. Next slide. Low-level measurement accuracy, particularly important in the coal-fired power plant industry, especially if you are at X today and you have to remove 90 or 95%, and we're not sure in the utility MACT what's going to be required. And frankly, we're not quite sure in the cement industry what's going to be required in terms of percent reduction, because in many cases, people don't know what the baselines are. We know what the end target is in terms of pounds per million ton of clinker, but we don't know what those concentrations and what the reduction percentages will be. And perhaps the Albemarle people will be speaking to what they're seeing in the industry there. Next slide. The EPA has released a traceability protocol for mercury calibration. Just real quickly, there are no gas cylinders for mercury that have proven to be consistent and accurate enough to be used to challenge the SEM systems, as there are for SOx and NOx and other pollutants. And so there are mercury generators. And EPA, if you look at that website link, in early July of 2009, in concert with NIST and a number of industry parties, including Tekran and other people, developed a protocol for these generators. These generators, a couple interesting points here. We may have to go up to over 250 micrograms per cubic meter to challenge these systems. We don't know what the high levels are going to be. The EPA protocol and NIST focused on coal-fired power plant, and the range there is between roughly about a half a microgram per cubic meter and 40 micrograms per cubic meter. So a little bit lower, perhaps, than what the PC MACT regulations might warrant. Next slide, Bob. In terms of the generators that Tekran uses in our system, we actually have 3 generators on board. One's inherent in our 2537 analyzer. A second one is elemental mercury with our 3310. And then we have a third generator. It's ionic mercury generator. It generates ionic chloride with an atomization and heating technology and some different dilution strategies. We can generate ionic and elemental mercury over a range of concentrations. NIST has a traceability protocol for the elemental. They do not for ionic at this point. In terms of how long do these generators last, they can last for years, but the EPA NIST protocol says, hey, you only have 8 rolling quarters to demonstrate that these generators are traceable back to NIST and that they're accurate. Tekran has the ability to compare our elemental generator to an onboard permeation source, which gives us this 2-year window of potential compatibility for NIST traceability and certification. We have a hot swap program, and that rack of instruments there is really a number of our 3310 generators that are on hot standby. They're traceable to NIST, so if somebody's generator in the field goes out, we can ship them overnight a generator that's traceable back to the National Institute of Standards and Technologies. It's really like shipping out a new gas cylinder. In this case, though, the gas cylinder has the potential to last for 2 years, assuming it meets certain accuracy and stability criteria. Next slide, Bob. There's the mercury, or rather gas bottles with a red line through it. My intention there was to indicate to the group there are no mercury gas cylinders. You got to use generators, as I indicated before. Next slide, Bob. An extremely important aspect of the mercury and other pollutant SEMS process is the commissioning and training and aftermarket service and support. I admit to this group that we have some utilities that have been using our equipment for 3 or 4 years, and they have relatively low percent monitor availabilities. We have other utilities, and the actual data is shown for one of those in the right-hand side that have high percent monitor availabilities. And the main difference, in my opinion, in those 2 groups is that the training and the focus and the commitment that both parties made to understanding how to operate the SEM systems, and they're new to the plant, and the plant resources are already strained. We're very familiar with that problem. These systems are not just turn it on and walk away. They require certain monitoring. In fact, we have remote call-in, Bob, that we can do remote diagnostics for all of our units in the field that have connectivity. But in any case, I don't want to have people diminish the importance of the training and aftermarket service support. I don't know, honestly, what the percent monitor availability threshold is in the PC MACT or the new utility MACT. But even if it's just 70 or 80% and not 90 to 95%, without proper training and service and support, the systems may not meet those thresholds. Next question here. I should have injected that earlier. This graph simply shows the fact that trying to get that last 10 or 20% of mercury removal, and this happens to be a coal-fired plant, but the physics and the chemistry and the removal process is the same nonetheless, is it costs a lot of money to get that last 10%, and if you're measuring low concentrations and you're doing it inaccurately, you can be spending a lot of money overshooting or overcompensating for improper measurements of things like mercury, but it could apply to total hydrocarbons, HCl, etc. So make sure that you have accurate low-level measurements, which leads to the next slide. The Electric Power Research Institute thought that this was important, as did the Illinois Clean Coal Institute, and they commissioned a study And the results of this study done up at the Energy and Environmental Research Corporation facilities in North Dakota are shown in those graphs. Bob, I assume you're going to share these with the group later on?
That's correct.
Okay, and next graph. Bob, are you moving to the next one, or is mine stuck here? There we go. There were some low-level RADA measurements at a utility. Go to the next graph. Okay, I think we might have skipped over one, but the bottom line is that there are third-party data available on mercury measurements at low levels and the accuracies of those relative to reference methods, and they're in this presentation. Final wrap-up here, Bob, for this, and thank you for the time again, is the the Portland cement industry is faced with new pollutants. They're going to have new SEM systems. There's an absence, in my opinion, of extended baseline data. Therefore, it's going to be tough to specify pollution control strategies. There's a lot of work to do in the understanding the CEM systems. One of the real key things here is what are the economics of the compliance of the PC to the PC MACT rules, and what units are going to make it and which ones may be retired. There's going to be supply chain resource issues here. If it's like the utility industry when the Clean Air Mercury rule was involved, people, and logically so, wait, and then at the last minute everybody needs their SEMs and they need to get baseline data, and everybody has to pick activated carbon or other pollution control technologies suppliers and move forward. We only have 2.5+ years left, and it seems to me we're running out of time. And it also seems to me that we can't develop accurate budgets, even ones within a factor of 25 to 50%, until we get additional information. So the question is, now what, and what is the plan of attack, because the clock's ticking. And Bob, thank you for allowing me to share the perspectives and some of the issues that we faced in the coal-fired power plant area, and some of the learning process that we've had in the last couple, 3 years in the cement industry.
Very good. I think while I'm getting everybody unmuted to ask questions, I'll ask the first one.